Hello friends, this video on chemical bonding part 16 is brought to you by examfear.com. No more fear from exam. Before watching the video, please make sure that you have watched part 1 to part 15. So let's start with the valence shell electron pair repulsion theory. The name sounds a little scary, but it's very easy to understand. If you just understand the name valence shell electron pair repulsion, that means repulsion by valence shell electron pair, right? So these valence shell electrons, they repel, and that determines the shape of the molecule. That's what this theory says. So the reason why we study this theory is because we know that till now we have studied the Lewis concept, and with Lewis we are not able to find the exact shape of molecule, right? Because Lewis doesn't help us find the exact shape of molecule. So this theory was proposed to provide shapes of covalent molecules. Please note, this is for shapes of covalent molecules, only for covalent molecules, right? These two terms are a little critical. This theory is for the shapes of covalent molecules. Proposed in 1940, and it is based on the repulsive interaction of electron pairs in the valence shell. So if you see the three words, electron pairs in the valence shell and repulsive. And this is what would make this theory, valence shell electrons. So we have some valence shell electron pairs and they repel. So with that we have this called valence shell electron pair repulsion theory. And it is pretty clear with this balloons we have. So you have two balloons. The balloons will try to become a linear shape because there are only two balloons. If you have two balloons the same size and try to bind it, it will take a linear shape. If I have three balloons, it will take a trigonal planar shape. You can try it in your home also. If you put four balloons of the same size, it will try to take a tetrahedral shape. If you put five balloons, it will try to get this shape. The natural shape will be the trigonal bipyramidal shape. If you have six balloons, it will try to take octahedral shape. That will be the natural shape of the six balloons of equal size. And same thing applies here in this valence shell electron pair theory. Instead of balloons, we have one orbital which has two electrons like this. They'll try to repel each other the way the balloon repel each other, and they get this shape. For example, in this case, right? These will have two electrons each, and they try to repel each other, and thus it gets this kind of shape. If this is clear, we can explain this in more detail, but just understand that it will either get the linear geometry, or trigonal planar, or tetrahedral, or trigonal bipyramidal, or octahedral, based on the number of balloons. Right? So in this case, generally the angle will be 180 degree. In this case, it will be 120 degree. In tetrahedral, my angle is 109.5. And trigonal bipyramidal, these angles are my 90 degree. And in octahedral, and these angles are 120, these angles. And in these octahedral, everything is 90 degree. All angles 90 degree. So let's understand this. For example, I have two balloons. These are my two balloons. There are two balloons, and they repel each other. Similarly, if I have a atom here, and this atom is linked to another atom, and they repel each other. For example, let's suppose I have beryllium here, and I have two chlorine molecules here, two chlorine atoms here. Okay, so beryllium has two electrons in the outermost shell, and these two electrons are used by these chlorines. They'll form a bond, and I'll get something like this. So in this beryllium, if you see, there's an attraction from the repulsion from this chlorine and this chlorine. Both will want to be away from each other. Correct? So this chlorine and this chlorine would like to be away from each other, and they'll try to squeeze. They try to pull each other. For example, this chlorine will try to get away from this blue. Both this will repel. And since it is similar to two balloons, you have two balloons, it will be a linear structure, right? And thus you will get a linear structure. Correct? So if I have three molecules like this, then they will again try to repel each other. For example, in this case, if you see, all these three are, I just put the balloons here, all these three will repel each other. Correct? For example, I have, this is boron, and I have these three chlorine molecules here. So boron has only three valence electron, and each of these is used here. Right? Only three valence electron to draw the Lewis structure. So all these chlorine will repel each other. They'll pull. Thus, it will get this kind of shape. This was the linear shape, and this was the trigonal planar shape it will get. Correct? If it is something like this, so let's suppose this is methane, for example. I have this carbon here and 4 hydrogen atoms here. So all these 4 hydrogen atoms will repel each other, will try to be away from each other, and then they will form this kind of shape, and this shape will be tetrahedron shape. This angle will be 109.5 degree. Here the angle will be 120 degree. Similar to the balloon example, right? They will try to repel, and they'll get this kind of shape, and this shape is called tetrahedron. This is called trigonal planar. This is called linear, right? Similarly, if you have something like this, so if you have 5 balloons, right? Now all these 5 balloons will try to pull each other. They'll try to there'll be distraction, there'll be repulsion among this, and they'll try to go further away from each other, and then they'll form this kind of shape, and this side of shape is called trigonal bipyramid. Bipyramid. And in this case, if you see, these angles will be similar to these angles. They'll be 120 degree, but it will be three dimensional. This will be 90 degree, and this is also 3 dimensional, right? If I have 6 repulsion thing, so all these 6 balloons will repel each other, right? And they will form something called octahedron. Here each angle will be 90 degree. You take any angle, this angle will be 90 degree. So there are different kind of shapes possible, and generally we'll talk about variations of these shapes itself, right? But these are the basic shapes for valence shell electron pair repulsion theory. So you have valence shell electron pair and they repel. So it's valence shell electron pair repulsion theory. So it says that if they are like this, they are 2 atoms, they repel each other, and there are only 2 atoms attached to central atom, it will get a linear shape. If there are 3, I think there is no lone pair attached here, so it will get a trigonal planar. If it is 4, it will get tetrahedral. 5 trigonal bipyramidal, and it's 6, it is octahedral, right? So that's what we have seen till now. For example, we have seen BeCl2 will get a linear shape, BF3 will get a trigonal planar because it has 3. Tetrahedron will be example is CH4. You see the methane example, right? There is no extra electron in the carbon, right? And there are only 4 attached here, and they'll try to pull each other. Same for phosphorus pentachloride, it will be trigonal bipyramid. Correct? So the Vesper theory predicts that, or postulates that, the shape of molecule depends on the number of valence shell electron pairs around central atom. So we are concerned only about the valence shell electron pair of central atom. Correct? It says that pairs of electrons in the valence shell repel one another. Because if you see the electron, the valence shell, they're all negative charge. The electron is nothing but, the electron clouds are nothing but negative charge. So negative charge will repel. Basic thing which you have learned in physics, right? To equal charge repel. So here also you have two negative charge clouds and then try to repel each other. And they tend to occupy positions such way they minimize repulsion. So they minimize repulsion and maximize distance between them, and thus by reducing their energy. Here also if you see, energy is like a stress and they want to reduce stress, and they can do this by getting such a position so that the repulsion is minimum and the distance is maximum, right? And in this case the valence shell is taken as a sphere, because this is what the theory says. According to this theory, it is assumed that if you want to find the exact shape, the theory says that you have to assume this thing. It says that the valence shell is a sphere with electron pairs localizing on the sphere a maximum distance from one another, right? In linear structure we had issues with the resonance, but here the Vesper theory works for all the structures. And please note here in this the key concept here is we have something called lone pair and we have something called bond pair. We'll explain what lone pair and bond pair is. Just understand the interaction is highest for lone pair, and the next interaction is lone pair bond pair, and the least interaction is bond pair. So if there are two lone pairs, they'll repel more, and we'll discuss why. So thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.